You can solve many drawing issues using some form of a transform. And a transform is a class that alters the way a shape is drawn using mathematical manipulations. I could tell you we were going to study matrix manipulation, matrix multiplication here, which you would need to study if you want to dig deep into this, but they've made it simple to use these transforms, so you don't generally have to do that. You'll use the two-dimensional transform class to rotate, skew, scale, and move or translate objects. In technical terms, the transform defines how to map or transform points from one coordinate space to another coordinate space. And you'll always be working with a transformation matrix, which is the system.windows.media.matrix, which defines the behavior of that transform. We'll talk about the matrix now, but manage to never think about it again once we look at the higher level methods that make this easy. To do a transform, you must supply values for the M11, M12, M21, and M22. Those are row and column values. Row 1, column 1, row 1, column 2, row 2, column 1, and row 2, column 2 values in a matrix. Also the offset X and offset Y properties. You can use these values to cause specific transformations to occur. And if you want complete control over it, you'll end up using this 3x3 matrix, in which only 6 values are active. And the matrix looks like this. It's a 3x3 table of values. In the first row and column, you get a value for M11. The first row, second column, you get a value for M12, and so on. The values in the third column aren't used, but they make up part of this matrix, which is 3x3. There's a reason why in matrix algebra that we end up with a square matrix, and if you care to think about such things, you can, but for now, let's go on faith that we end up with this 3x3 matrix, which is used to perform matrix manipulations on shapes and transform them. By manipulating values in that matrix, you can rotate, scale, skew, and translate things. For example, if you change the offset X value to 100, you'll end up moving the object 100 pixels in the X direction. If you change M22, that is, the matrix value in row 2, column 2, to 3, you'll stretch an object to 3 times its height. You could operate on that matrix directly, and it's all built in to XAML, but normally you don't. Instead, you use built-in classes that inherit from the system.windows.media.transform class. For example, scale transform, skew transform, rotate transform, and translate transform, and they do all the work for you. They set up the matrix, they perform the matrix manipulation, and they skew, translate, rotate, or scale the shape accordingly. Now we have a number of different transforms we'll be looking at. There's the rotate transform, which rotates an element by a specified angle. Angle is there in italics because that's the property you'll specify of the rotate transform to transform the element. There's a scale transform, which scales an element by scale x and scale y, where scale x and scale y can be a number where 1 is 100%, 0.5 is 50%, and so on. There's a skew transform, which skews an element by an angle in the x direction and an angle in the y direction. Those numbers can be any representation of an angle in degrees. There's a translate transform, which moves elements by x and y pixels in the x and y direction. There's a composite transform, which applies multiple transforms to the same object and applies the transforms in a preferred order. You don't control it. And this is generally the best way to supply multiple transforms. On the other hand, you may want complete control over the order of the transforms, and you can use a transform group. In that case, you specify the order of the transforms. Finally, there's a matrix transform, and this is the lowest level. This allows you to supply values into the matrix you've already seen and perform the matrix manipulation yourself. We won't show off matrix transform in this course because it involves math that we don't have time to dig into. But if you're interested, you can look at that matrix transform class to do all the work manually. Transforms can be useful in many contexts. If you want to rotate a shape, use a rotate transform. If you want to repeat a shape, well, that's an issue altogether. If you want to repeat a shape, what do? Maybe you want to have a shape show up at different locations, but rotated? Transforming a single shape makes it certainly easier because you're only keeping track of it once. If you want to animate a shape, what if you want to rotate, skew, scale, or move a shape as part of an animation? Then you use a transform. So how do you repeat shapes? Well, the easiest way to do this is to use code. Anything you do in markup, you could do in code. You can create the shape in code and then create multiple instances of it. And you can do that. We won't do that in this demonstration. You could duplicate the shape in markup. This is inefficient and error-prone, but it's certainly the most common solution, and that's the one we'll be using here. And in Silverlight, these are the only two options we have. In WPF, you also have the option of using a resource. You can store the geometry for a shape in a resource, and then set path.data to that resource. Therefore, you can use that shape in multiple places by sharing that resource. This option isn't available in Silverlight. Our sample uses this technique, so we only create the shape once and then use it in multiple places by storing it as a resource. To rotate a shape, you'll use a rotate transform, and the markup for that might look something like this. You have a path with its properties set, and then we'll set the render transform property of that path. Render transform is the element you use for all transformations, and here inside that render transform, we'll have a rotate transform where the angle is, well, minus 15 degrees, rotates it backwards 15 degrees. Now notice that the render transform can only contain a single element. So if you want to group multiples of them, you'll use one of the two methods for grouping together multiple transformations. By default, the rotation occurs around the origin, the 0, 0 point of your shape. You can specify the center point by setting the center X and center Y properties. Here we'll just add those properties to our rotate transform, and now we'll use that point within the shape as the center for the rotation. Now you'll see in a bit there's a simpler way to do that as well, but you can always use center X and center Y to define what you're rotating around. Let's look at an example that demonstrates rotate transform. In this demonstration, I'll show the items in the first column here. Here we have a reference rectangle and line that I'd like to rotate by 15 degrees, negative 15 degrees, and unless you specify otherwise, it rotates around the origin for the shape, which is up here in the left-hand corner. If you want to rotate around a center point, you need to specify that center point, which I'll do using the center X and center Y properties. Let's look at the markup for this page to see what's going on. Here we have, up in the usercontrol.resources, a geometry group defined named rectResource, which defines a rectangle and a line geometry. We'll use those throughout this demonstration. The rectangle and line are defined here, so I don't have to define them every time I want to use them. The name of the resource is rectResource. Down here, within our first canvas, we have a path which uses that resource for its data, and a path which uses the same resource for its data, but instead of being gray with a stroke thickness of 4, this one's black with a stroke thickness of 7, and it also has a render transform. A rotate transform where the angle is minus 15 gets us this display. Down below, we have the exact same thing, and all I've changed is the center X and center Y properties for that shape, for that rotate transform. Given that center X and center Y, we now rotate around that point, and it appears like this instead. You can see what a difference setting the center X and center Y properties have on the result of this rotation. If you want to change the size of a shape or path, you can use a scale transform. You'll provide separate scale x and scale y values to control scaling in the horizontal and vertical direction. You can also set the center x and center y to indicate the center for that scaling. Because by default, they scale starting at the upper left-hand corner. You may decide you want things to scale starting at some other point within your shape. Let's look at an example that demonstrates this behavior. In this demonstration, we'll work with these two examples here in which we'll use the scale transform to change the size of a shape. Now, in this case, we're starting with the reference shape, which is this dotted rectangle and line, and we'd like to scale them to 1.5 the original size. Now, scale transforms, like the other transforms, perform their scalings around a certain point. In this case, we're using the point 0, 0. But because this reference object is positioned at coordinate 20, 40, when we scale it, that offset scales as well, so it moves down and to the right. If we want to avoid that problem, we can change the point around which the scaling occurs. And so if we change that center x and center y point, we'll move our shape or change it in a different way. If we look at the markup for this, you'll see that first we start with our original shape here, using the data coming from the static resource, and scale it using scale x and scale y values of 1.5. So our shape does become 1.5 times as large, but so does the offset from the upper left-hand corner because we're scaling from 0, 0. If instead we change the center point of our scaling to be 20, 40, now we're scaling around that point instead. You can imagine you're zooming in starting at that point, and given that, we see that we can maintain the position of the upper left-hand corner of this thing. You may need to modify the center x and center y coordinates. Generally, you make them be the center of the shape, but had we done that, this thing would have scaled up to the left and above the original shape. To keep the upper left-hand corner of the shape at the same coordinate, I used for the center point the actual coordinates of the upper left-hand corner of the shape. You'll want to experiment with center x and center y to determine what effect they have when you scale your shape. If you want to skew a shape in the x or y direction, you can create a skew transform. To do that, you set the angle x and or the angle y property, and the markup might look something like this. I'm only skewing here in the x direction. And again, I'm setting the center x and center y properties so things stay the same in the upper left-hand corner. Instead, they scale off in one direction only. So here, we're setting the skew transform as the render transform property of my path. Let's look at what these look like on screen. In these examples, we'll look at skewing a shape both in the x direction and the y direction. By setting the angle x property, we cause our shape to skew in the x direction, and by setting the angle y property, we cause our shape to skew in the y direction. You can, of course, combine these together in a single transform and skew in both the x and y direction. By default, if we just skewed this thing in place, it would have skewed all of the coordinates, including the upper left-hand corner. I wanted to keep that constant for this demonstration, so I also set the center x and center y property, so this thing skews around that point instead. If we look at the markup, you'll see down here that we're using the same shape we've used before, but now we just set the angle y or angle x property of a skew transform, which we've set into the render transform property of the path, and we skew this shape by 20 degrees in the x or y direction. Now, if you want to check it out, remove the center x and center y property values here, and you'll see that these will skew from the left-hand corner as well. By setting the center x and center y properties, I've managed to keep that coordinate the same. If you want to move an object to a new location, In that case, you'll use a translate transform. And this one's simple. You just supply x or y or both coordinates and you'll translate your object by that many pixels. Let's look at a demonstration that shows off using the translate transform. In this example, we'll simply take this gray reference shape and translate it in both the x and y directions using a translate transform. You can see it move to the right and down. If I look at the markup for that example, we start with the same shape we've been using before, stored away as a static resource, and we'll draw it first in gray with a stroke thickness of 4, and then in black with a stroke thickness of 7, and the difference is in the second version, we set the render transform property of the path to be a translate transform, where we translate both 20 units in the x and the y direction. Now don't forget that you can combine these things together using a composite transform. That is, you could both translate and skew the shape in one transformation using a composite transform. We haven't done that here, but you definitely can using multiple transforms combined together. Although you can set the center x and center y coordinates to indicate the center of the transform, as you've seen in every example we've worked through, absolute coordinates can be somewhat tricky to calculate. You have to know exactly where within your container you want to work with, and how does this interact with a margin or a canvas.offset or any of the other things that can move things around. It's easier to use coordinates that are relative to the shape itself. To do that, you can set the render transform origin property. In that case, 0, 0 is the upper left-hand corner of the shape, and 1, 1 is the lower right-hand corner. The center of the object, no matter what its shape, will be 0.5, 0.5. So if you want to perform some sort of transformation around the center of the object, you can set the render transform origin property to be 0.5, 0.5, and then you don't have to worry about the absolute coordinates. Let me show you an example where we rotate an object around its center. I'd like to take 5 rectangle shapes and rotate them. Now, the first time, I'll rotate them around their endpoint, and that's pretty easy. So let me show you what that markup looks like. And this is one of those cases where doing this in code might actually have been a lot easier, because here I take my rectangle shape, and it's the exact same rectangle shape copied 5 times, and for each one I just use a different value for the render transform property. Here I use a rotate transform of -20, then -40, -60, -80, and -100 degrees. And so we rotate starting here 20, 40, 60, well this one's already 20, 40, 60, 80, and 100 degrees. So we've rotated around the endpoint, and that's what this looks like. But what if I want to rotate them around their center points? I could do the math and calculate exactly where that center point is, but it's much easier than that. All I have to do is specify the render transform origin for the rectangle. I'll do that on each rectangle, and then all transforms use that as the center point. I only have one transform on the rectangle, but if I had more than one, it would still use this as the origin for that transformation. Given that transform origin at 0.5, 0.5, when I rotate by -20, it keeps the center point fixed and just rotates around that point instead. So you can see that it would have made all of our previous examples easier had we used the render transform origin property to indicate what point we want to transform around. Rather than having to do it in absolute coordinates, we could have done it at 0, 0, the upper left-hand corner of the shape itself. In any case, if we set the render transform origin to 0.5, 0.5, it's the center of the rectangle right about there, and every rectangle then rotates around that one point. This one is rotated -20, 40, 60, 80, and 100 degrees around that center point. You'll find it easier, I'm guessing, to use the render transform origin property of the shape when you want to perform some transformation around a coordinate within the shape itself. Every transform you've seen works with one or more UI element objects, that is, shapes or paths. Applying a transform to a framework element, that is, like controls, you can create and apply a transform to the render transform property, and this occurs after the layout of the controls. This can affect your layout in unsuspected ways. For example, if you have a stack panel, and in that stack panel you have a number of buttons, and say you apply a transform, a render transform property, to the middle button that scales it bigger, what's going to happen to that bottom button? Well, if you scale the middle button bigger, it's likely to overlap the bottom button, and this occurs because the transform occurs after the layout. There's not much you can do about it in Silverlight, so you just have to plan ahead to make sure you understand the transform behavior and how it interacts with the layout system. Let's look at an example that proves this point. Here I have three versions of the same layout. I start with three buttons in a stack panel with a margin of 10 pixels, so I have space between them. Then I set the render transform to be a rotate transform. Remember, the render transform occurs after the layout. So WPF first lays the buttons out like this, and then rotates this button around its upper left-hand corner, and it ends up looking like this. If we set the layout transform, though, it's slightly less efficient, but may look more like what you want, because in this case, the transform occurs before the controls get laid out. Here we have the first button, here we have our rotate transform, and then our third button here. So this then pushes that third button down to make room for that rotated second button. What does the markup for this look like? If I scroll down here to find those three buttons, there we are. There are the three buttons in a stack panel. Here is the second stack panel. What I've done is set the layout transform property of the button to be a rotate transform, rotating by 45 degrees. Then we have the third button in the same place it always was. In the third example, the only difference is we set the render transform property, not the layout transform property. And it looks like when you use the layout transform property, it also alters the shape to make it fit within the layout better. So you may have to experiment with layout transform and render transform properties of your controls, because clearly they interact with the control differently, and they modify the layout when you're using something like a stack panel to contain your controls. Remember, if I was using a canvas here and things were in fixed positions, this wouldn't affect anything. But because we're using a stack panel, the behavior of the render transform versus the layout transform is different, and you need to be aware of that difference. You can use transforms to create rich and varied effects in your applications. The trick is to figure out which transforms provide the effects that you want. Say, for example, you want to create a reflection effect, make it look like an image is being reflected in water. To do that, you can combine a scale transform and an opacity mask. What you'll do is place your image twice, and to the second image apply a scale transform using 0.8, but negative, as the scale Y value. That flips it over and makes it 80% as tall as it was. Then add an opacity mask. The opacity mask allows it to fade out at the bottom. You can see exactly what's going on here. I took the image of the dog and placed it twice on my application. For the second one, I applied a scale transform. Negative 0.8 flips it over, makes it a little shorter because the reflection is not quite as tall as the original, and I added an opacity mask which causes it to fade to transparent at the bottom of the image. So it looks like it's reflected in some way on a mirror or water or whatever. Let's look at this example for real and see how that works in the application. In this example, to create our reflection image, you can see I've got two copies of the same image within the grid. The first one occurs at row 0. I didn't specify that because that's the default. And the second one occurs at grid.row1. so it goes into the row number 1 within the grid. Now the question is, where do I put it? If I don't specify a render transform origin value, the image doesn't go where I want it at all. It goes sort of up and it doesn't look right. It doesn't look right, of course, because I flipped it with a negative scale value, which makes it look even worse. If this was a positive scale value, you'd see it would appear down here, but it still wouldn't render exactly the way I want. So to get around that, I've added a render transform origin to push it down so the paws just touch right there. So you'll need to play with that render transform origin value to get your reflection to look correct. I also have a scale transform applied to the render transform property, and I've set the scale Y property to negative 0.8. That scales it upside down and also makes it a little bit shorter, well, 20% shorter than the original. Why negative? Because if it wasn't negative, it would appear positive, and that wouldn't look quite right. No reflection's going to look like that. So we'll flip it over, and now we have the basics of the reflection done, but we also have to add the opacity mask. By setting the opacity mask property to a linear gradient brush, you can see we've gotten the reflection behavior we want. One thing to note, this is a vertical gradient. It starts at 0, 0, ends at 0, 1, and that seems right, but we have at offset 0 color transparent. Shouldn't 0 be up here? And that would be true, except we've applied a negative scale, which flips it over, which means that 0 is now down here. So this is our 0, it's transparent. Up here is our 1, and it appears in black. Now, why don't I see black? Just remind you again, an opacity mask only cares about the alpha value of the color you specify in the gradient. Since black is fully opaque, so is red or yellow or green or blue or any color, all we care about is that alpha portion, which indicates fully opaque, and so we start out opaque here and become transparent as we move down the image. And by doing this and using this technique, combining a transform and an opacity mask, we've managed to emulate a reflection look, and this is pretty much how everyone achieves this result.